Hello, my name is Tom Ruberto, and I'm a PhD candidate at Arizona State University, studying geology and geoscience education. My research involves the use of interactive, immersive virtual field trips as a learning modality. I wanted to take a few minutes today to share some of my recent work, along with the works of colleagues at ETX, the Center for Education Through Exploration. ETX is committed to inventing the future of digitally enhanced education at planetary scale. So today I'll be sharing my research motivation, a brief introduction, background and research questions, a discussion of the existing research, and then my current research project. I just want to share that working on a PhD in my late 50s has been a very rewarding but challenging experience. Throughout this journey, I've been guided by the following quote: "For in the end, we will conserve only what we love. We will love only what we understand. We will understand only what we are taught." My motivation is to facilitate the widespread production and consumption of geoscience virtual field trips as a tool to help students navigate the promises and perils of the Anthropocene. I'd like to provide some scaffolding to help explain the context of my virtual field trip research. Learning is a long-held core requirement of geoscience education and regarded as an effective way to learn geology. Field learning occurs in places and is by its nature an example of place-based education. By naming, exploring, inhabiting, imagining, or experiencing a locality, we give it meaning and transform it into a place. Instead of focusing on global concepts, place-based geoscience teaching uses the natural and cultural meanings of a place as context for transdisciplinary scientific study. And in place-based education, place becomes an organizing theme that dictates curriculum and methods of instruction. However, not all students enjoy equal access to in-person exploration because of time, cost, safety, distance, instructor variability, physical ability, and most recently, the COVID-19 pandemic. iVFTs may be the only practical option for most students to explore pedagogically rich but inaccessible places. Representing the next generation of digital field experiences, the iVFT is novel in that it marries multimedia elements from traditional virtual field trips with an intelligent tutoring system. High-resolution and visually stunning multimedia components are delivered to two-dimensional screens via the internet and reside within a software platform. This creates an active, student-centered learning experience that allows pupils to ask and answer questions while providing them with embedded assessments and real-time feedback with intelligent tutoring. iVFTs are considered a form of place-based education. While these place-based experiences traditionally occur in physical places, a digital learning experience conveys an actual place virtually. The following design elements can be applied to the development of a virtual place-based learning experience. 1. Focus content on the natural attributes of the place under study. 2. Meaningfully integrate cultural attributes of the place under study in appropriate ways to add context and relevance. 3. Teach with authentic experiences in that place or in an environment that evokes that place. 4. Promote environmentally and culturally sustainable practices and policies relevant to the place under study. And 5. Encourage and guide students to form their own intellectual and emotional connections to place. Researchers at ASU have developed a set of iVFT design principles called ETX, or Education Through Exploration. The principles suggest that iVFT producers should 1, convey authentic science, 2, design lessons with an overall narrative and a personal story, and 3, take advantage of what a digital learning environment can do that would be impossible conventionally. The goal of the ETX design principles is to create a virtuous cycle in which curiosity leads to exploration, which leads to discovery, and ultimately further curiosity. My associate Chris Mead showed that iVFTs created using the ETX design principles led to statistically significant content knowledge gains in high school and undergraduate settings. A recent mixed method research project, it was actually my master's thesis, explored the implication of learning outcomes of in-person and virtual field trips at Grand Canyon National Park. Both groups experienced pre to post learning gains. However, pre to post trip concept sketch scores of the Great Unconformity showed the measured learning outcomes of the iVFT students were 3 times greater and statistically significant than those of the in-person students. It should be noted that the iVFTs developed by the Center for Education Through Exploration at ASU are time and resource intensive. They require professors and subject matter experts, project managers, instructional designers, photographers, videographers, multimedia producers, computer programmers, graphic artists, and logistical staff. Once armed with this evidence-based research showing the effectiveness of iVFTs as a learning modality, ETX researchers began to explore more ways to get quality iVFT content into the field. Simply, can students and teachers be given the tools to produce iVFTs using the ETX design principles and core components of place-based education? In an effort to understand if students and teachers could produce iVFTs, the following courses and projects were undertaken by the Center for Exploration Through Education in conjunction with the following schools at ASU: the School of Earth and Space Exploration, the School of Sustainability, and the Walter Cronkite School of Journalism. These classes, camps, and teacher projects produced 9 virtual field trips. The courses and projects previously mentioned were designed to prove a concept. They were not designed to study learning gains and outcomes associated with the production of an iVFT. Those projects led to the following questions. What affordances and hindrances do students encounter when producing a place-based, immersive, interactive virtual field trip for the digital realm? How are content knowledge and sense of place learning outcomes impacted for students who produce a virtual field trip? And can differences in content knowledge and sense of place learning outcomes be accurately measured between students who consume a virtual field trip and students who produce a virtual field trip? And if so, how do they compare? Existing research and theoretical frameworks can be used to explain the anticipated gains in sense of place and cognitive, affective, and behavioral learning outcomes by students producing an iVFT. As mentioned, iVFTs are place-based experiences. An increased sense of place is a PBE learning outcome with cognitive, affective, and behavioral components. iVFT production is an exercise in hands-on active learning in the real world. iVFT production appears to reach all levels of Bloom's revised taxonomy. It also appears to reach all levels of the ICAP framework. iVFT production is time intensive. Time on task increases learning gains, and sense of place increases with time. Analyzing the meaning of a place through photos and videos increases sense of place. And students capturing photos and videos can navigate Massey's criticism of a place being static, and in the process, create a dynamic sense of place. My current research will attempt to answer the previous research questions. Again, we're going to offer a new iVFT course that's designed to answer these questions. It will be offered in the fall and spring. It will target 18 students. We'll choose the topics in advance, and we'll assemble and administer surveys and validated instruments so we can measure sense of place, content knowledge, attitude, and behavior. The students will be responsible for delivering the iVFT and weekly reflections. And each course offering will produce 18 data sets from iVFT producers and 90 data sets from iVFT consumers. And those numbers will be doubled when we offer the course twice. The following validated instruments will be used to collect data for the project. CURE, the classroom undergraduate research experience, collects demographic information and measures student satisfaction with science in general and science classes. The positive and negative affect schedule, the PANAS, measures students' affect realm. The place attachments inventory and Young's place meaning survey are both validated instruments that measure sense of place. The geoscience concept inventory measures content knowledge, and we'll also be developing specific content knowledge assessments. And then qualitative analysis will be performed on student reflections, semi-structured interviews, and direct observation of student behaviors. We'll also administer an iVFT technology survey so we can understand students' pre and post familiarity with the components of producing an iVFT. My apologies for this very dense screen, but in a nutshell, here are my anticipated results. For my first research question, what affordances and hindrances do students encounter when producing a place-based immersive interactive virtual field trip for the digital realm? Null hypotheses are not applicable here. This is a process question that will be answered by observation. And I expect to compile a comprehensive list of affordances and hindrances that can be used for a best practices guide. My second question, how are content knowledge and sense of place learning outcomes impacted for students who produce a virtual field trip? My null hypothesis here is that students producing an iVFT will not experience content knowledge and sense of place gains. Based on previous research in the literature, I expect to reject this null hypothesis and show that students producing an iVFT experience statistically significant gains in content knowledge and sense of place. And my third research question, can differences in content knowledge and sense of place learning outcomes be accurately measured between students who consume a virtual field trip and students who produce a virtual field trip? And if so, how do they compare? My null hypothesis here is that content knowledge and sense of place gains will be equal between students consuming and producing an iVFT. Again, based on previous research in the literature, I expect to reject this null hypothesis and show that although consumers and producers both experience gains, producers will have statistically significant higher gains than consumers. This graph looks a bit confusing. Let me quickly explain it. I have a first class, last class, and then 4 milestones. I break the iVFT production process into 4 milestones. They are research and storyboarding, content acquisition, design and production, and testing and implementation. And here, I track content knowledge, sense of place, and then positive and negative affect, and what I expect to happen from the first class through those milestones and the last class. So as you can see, I expect content knowledge and sense of place to increase significantly. And then my positive and negative affect, I expect them to mirror each other. And my experience has been that students start out relatively neutral. Their positive affect goes up in the beginning of the class. You'll notice a sharp decrease between milestone 2 and 3. That is design and production. Typically, students here are battling the learning curve of video editing, image editing, designing graphics, and then learning how to program the intelligent tutoring system. And you can see my negative affect is the mirror opposite of the positive affect. Why is this research important? Well, the question, what affordances and hindrances do students encounter when producing a place-based, immersive, interactive virtual field trip for the digital realm? This should contribute to the development of best practices guide. It should reduce the learning curve for iVFT production and democratize iVFT production by lowering the barriers to entry for both students and teachers. How are content knowledge and sense of place learning outcomes impacted for students who produce a virtual field trip? This should show instructors that assigning an iVFT production project or research experience can produce positive cognitive, affective, or behavioral learning outcomes. And then finally, can differences in content knowledge and sense of place learning outcomes be accurately measured between students who consume a virtual field trip and students who produce a virtual field trip? So learning gains experienced by consumers will incentivize instructors to use iVFTs as a learning modality. And then establishing a baseline learning level for consumers will allow developers to improve iVFTs. They can introduce new techniques or new technologies and compare to the baseline to see if those new additions have increased learning outcomes. Thank you for sharing in my research. Again, my name is Tom Ruberto. If you have any questions, please feel free to email me at truberto@asu.edu. Thank you.